Hello, Fusha. That's a pretty late level for part 1. Oh, I get it. Okay. Yeah, this is the kind of game that doesn't have many like wallpapers online because no one cares about making wallpapers for it, so that's the best I could find. Normally I'd try and find some like cinematic looking background like image for it. Alright, so this is actually the prequel to a game I played a few months ago, well, probably years ago at this point, called... What was it called? 7 Billion Humans? Something like that. I didn't realize that this was the first of the series. I thought I was playing the first of the series, so... Apparently it's not as good as 7 Billion Humans, and they improved a lot in the sequel, but it seems good. Feel free to ask me for my amazing solutions to be amazed at how efficient they are. So you played this, have you? Have you played 7 Billion Humans as well? I'm trying to find all the games which are like programming games, because there's not many of them, and I've played a few, and some of them are pretty good. I mean, there's the whole what's that group called that makes the like Shenzhen IO and stuff like that. I forget the name of the team, but they've made a whole bunch of different programming like games which are very popular. Zacklike, that's it, yeah. That photo looks just like me. Okay, so it's definitely like the same format as 7 Billion Humans. I've heard people said this game is a bit more assembly-like, or like assembly code, which was kind of a bad thing because nobody likes assembly. But hang on. I should probably rearrange this because this is going to be covering up stuff all the time. Okay. I need to move the chat window as well. Nobody likes assembly, everyone wants to use the TIS 100 programming language instead. I have TIS 100, that's also on my list. I played Space Chem, which was one of the early Zack-likes. That is the single hardest game I've ever played in my life, and I still haven't finished it. I think I'm on the very, very last mission. That is absolutely brutal. Even the devs... No, even the lead dev who made that game has not beaten the final mission himself. So, I think the team behind that game actually admitted in some interview that they think they made it a bit too hard and they learned from that experience when making their next Zachtronics games, but... Your program should tell your worker to grab each thing from the inbox and drop it into the outbox. So inbox... Okay, it would be nice if they told me these requirements up front. Do they? Oh, don't exit. Oops. Campaign 1 is levels from the author. Campaign 2 is levels from other people that the author hasn't necessarily beaten. Are you talking about Zachtronics games in general or Space Chem specifically? I guess they want us to do this 3 times. Ah, tell me more, tell me more. Okay, fine. I've played Space Camp, but the other ones are like that. I don't know if that was the case for Space Camp. I don't think so. There was a whole interview with the devs. I think they made all the levels. Grab each thing from the inbox and drop each one onto the outbox. Exapunks, I think I might have that now. I think it came in one of the big itch.io bundles recently, like the Ukraine something or other. Inbox conveyor system is completely broken, but that doesn't mean we get to take a break from work. Ignore. Okay. Okay, fine. I guess it takes a copy instead of actually picking up. Ah, I see. Oh, okay. Whoops. Oh, you can only hold one at a time. Scrambler handler. Grab the first two things from the inbox, drop them into the outbox in the reverse order. Repeat until the inbox is empty. Okay. So we pick up, copy to 0, fine. Then what happens if we do that? So we have an infinite generator. Okay. So if we were then to just inbox, what happens? Oh, he chucks it. Okay, okay, got it. Alright, so then we take what's next, deliver that, copy from 0, deliver that. Does that work? Put that there, chuck that. Okay, this copy thing is interesting because it's a bit different to how 7 billion humans does it. So yeah, these are the guys that made World of Goo, which was a great game as well. But completely different style, bridge building. Rainy summer. Cool rain graphics. Each 2 things in the inbox, add them together and put the result in the outbox. Okay, fine. Grab something. Each 2 things in the inbox. Okay, so put it there. What's he wanna tell me? Oh, no, we're fine. Alright, put it there. Pick up the next one. Add whatever's in 0. Hello, Bug Plugged. Love this game. Have you... Nice. Have you also played the sequel? Oh, okay. I've only played the sequel, and at the time I didn't realize that this game was actually the prequel. So... checking out this one. Guess I can just deliver this now. Would that work? So far they don't seem to have criteria for getting like bonus stars in this one. It seems like you just beat the mission, maybe. Yeah. I never really got all the bonus stars in the sequel. I got maybe 2/3 of them or something. I suppose this is the wrong day, but I figure out where you went wrong with day 16 part 2. I think you mean day... Yeah, day 16. I also figured it out, and I figured out in the middle of the night. I woke up at like 5 AM with a jolt. I suddenly realized where I went wrong. I'm not even making that up. And then the next day I streamed the rest of it. What was it again? It was... My assumption was that doing the steps of the dance are equivalent to 1 permutation, fixed permutation, but that was wrong because letters are moved around, letters are rotated. So it's not equivalent to 1 permutation. Upon further investigation, I have in fact finished 7 billion humans and got all the stars. Nice. Congratulations. I'm gonna have to go back and get all the stars at some point. So really just look for repetition. So it turns out that the letter swaps don't matter because 1 billion is a multiple of 2 and 4 and 5, and all these cycles of letter swaps are of length 4, 5, stuff like that. So they all cancel out, so you can just skip all the letter swaps altogether. But if they were to form a cycle of length 3 or 7 or something, that doesn't evenly divide a billion, so you can't cancel them out. But that doesn't happen with the this example, so alright, 0 exterminator. You basically did the smarter way of doing it, and that's what ChatGPT did as well. You just do the dance until you see a repeat, and then just and then you immediately have the solution. Basically, you can just where it's going to end up at a billion. I don't know why I didn't think of doing that. That is actually the way to solve several. It's smarter because it's faster, and at the end of the day, whatever's faster is smarter, surely. If you're good being competitive for Advent of Code. What kind of game has dance maths? So I'm referring to Advent of Code, which was something I've been streaming as well, which is the problem in question was involving a dance where you have elements in a row and then doing a dance where they swap places. Autonauts is a great coding game. Let me check. I feel like I own that as well. Check my GOG library. Owned games. Auto. No, I don't. But yeah, I've heard about that. Autonauts. The dreaded question, where do you see yourself in 5 years? Send all things that are not 0 to the outbox. Okay. Take something. Put it down. If I'm carrying 0, go back to the start. Deliver what we have. Go back to the, and just jump to the beginning. Oh, now they introduced the challenges. Okay, so I'll mainly focus on just beating the levels, and then one month in the future, I might come back to the challenges. But every now and then, I might. So 4 or fewer commands. Obviously, you need inbox and outbox. So one of the jumps, I guess. Wait, you might... Oh! We don't actually need that, do we? He just chucks it. Oh, that makes sense. If there's something I think I can do pretty quickly, then I'll do it, but I won't spend too much... Well, what I mean is I won't spend too much time on any challenges. Because in 7 Billion Humans, there were some challenges where you had to write some pretty obscure code in order to achieve them. And then you have to rewrite it a completely different way to do some of the like a different one of the objectives. So these optional levels. I mean, I do all the optional levels as well. High-performing employees, that's me? Sure. Why was my AC set to 25? It's really hot now. Had to actually do actual real-life sorting algorithm research. Yeah, that wouldn't surprise me. you are building sorting algorithms from first principles and things like that. But with more limited mechanics than what you have in, you know, in any standard like imperative language. Each thing in the inbox, triple it, and outbox the result. So now we should be holding triple it. So we put that down, add it to itself, add it to itself. Okay. That must be optimal, surely. Send only the zeros to the outbox. What happens to the other numbers and letters? Send only the zeros to the outbox. Okay. So can we just do what we did before, but instead we say we jump over a jump. So we pick something up. Wait, no, we didn't need to. Like that? Oh, we would, okay, change this jump to like, not that it really matters. Wait, what happens if I do that? Would that be optimal? Wait. Huh, it is. Speed challenge. Complete in 25 or fewer steps. Oh yeah, because reading each one of these commands kind of incurs time. I can't remember how it's defined. I remember it wasn't very clear when I was doing 7 billion humans, but okay, so just do that. How long does that take? Because then we're reading the extra jump command. 28. So we pick it up. Every step that has a number before it gets counted. Okay, yeah. Oh, it's going to be something like we just take this whole lot and just paste it lots of times so that we can eliminate this jump, isn't it? Can I be bothered to do that? Okay, yeah, I can use copy and paste, it won't take that long. So we... Yeah, but this is not going to... Okay. Okay. That won't actually take that long if there's only... Is that all there is? Or is there more from the input? So... We won't even need it that many times, because we only have to... Probably 3 times at most. We only have to jump for the non-zeros, so... Hang on. Wait, so let's do that. I used copy and pasting in 7 Billion Humans, but not the in-game version. They had it copies it to your actual clipboard. So if you go into Notepad or something, you can actually paste it, and then you can. It's easier to, like if you're using Visual Studio Code or something, it's easier to manage it there, and then you can paste it back in from there, and it will paste it correctly. I don't know if that works in this game. I'll have to try that when I actually need it. Hang on, this is working, isn't it? Yeah, so now we just... So what was the point of this? Oh yeah, we eliminated one jump. The one that comes after outbox. Okay, so yeah, just keep doing this. Wait, can we also just do that? Oh, it doesn't matter really. Let's just make it symmetrical. Okay, one more. Oh, what happened? Ah, no. Not doing this correct. I probably... Okay, and I'm gonna need one more after this, aren't I? No, that's fine. Oh, there's other inputs. Alright, let me see this input. Yes, here, I'll give you some... If we just change this jump here to go here, will that... Okay, there we go. Hello, Romero. We're doing some programming games. As you can always... this is kind of... You basically write sort of like assembly-like code to instruct these humans to move numbers about and add them and try to meet the objectives. It's kind of like low-level drag and drop programming. Pretty good for introducing people to the concept of programming who have never done programming. But on its own, it is actually quite tricky, some of the challenges, so it's a puzzle game. Each thing in the inbox, multiply it by 8 and put the result in the outbox. Okay. So we take something, we copy to, add it to itself. So we're now holding double. We're now holding 4 times. Okay, we should now be holding 8 times. And I guess to save time, you can always just paste that whole thing over and over again. I think I won't worry about those types of challenges. Oh, it was actually fast anyway, even though the jump, you could actually eliminate the jump. I guess they really wanted to emphasize that you can double it repeatedly instead of adding it to itself 7 times. Subtraction, I never learned that in school. Did you? For each 2 things in the inbox, first subtract the first from the second and put the result in the outbox. Subtract the first from the second. So sub, I guess you're actually subtracting what's on the floor. Okay. Inbox. Looks pretty easy so far. Yeah, I mean, they're teaching us the basics, like adding and jumping. Pick something up. Put it down. I guess we want to pick another thing up. Subtract whatever's in 0. Output that. And then the next thing we want is subtract the second from the first. Okay, so I guess we want to put whatever we're current. Oh, I see. So we're gonna have to store the second item first. No, I'm trying to click on 1. There we go. So now we pick up what is in 1. Well, so far there's no way to clear what you've put on the floor. Again, oh no, there is. You can put something else on it. Okay, sort of. Yeah, that's sort of clearing. Sub 0. And an outbox. Alright. Oh. So we pick that up, put it in 0. Ah, no. Oh, no, stop. We should be holding... Oh, whoops. Okay. That should be... Zero. That should be 1. Wait, alternatively... Let me just try a different approach. Alternatively... whatever you're holding, you can just subtract itself twice and you'd get the negative when you... Or a positive if it was negative. So you wouldn't need to... I don't know if that would actually be faster or whatever. So once you output that... You can now put whatever you have in, I don't know, 1. Subtract that again. This is probably going to be the same. No, wait. What was I holding? Hang on. I didn't reason that out correctly. So, pause, damn it. Oh, when you out... put... Oh, never mind then. When you outbox, you lose what you're holding. Okay, alright, fine. That won't work. 12. My coffee tastes of spinach because I boiled it in the same pan I was cooking spinach in. I don't think I cleaned it thoroughly enough. Not that that's a bad thing, it tastes fine. But a few days ago it tasted of squid. Now that was quite bad. Squid coffee. Each thing in the inbox multiplied by 40 meant you get coffee every time you clear both challenges. Oh, I didn't even notice that. For each thing in the inbox multiplied by 40 and put the result in the outbox. By 40? Okay, fine. So we pick something up, copy it to 0, so either we keep doubling it up until we get to 32. But when we get the 8, we put that down somewhere. So, okay, let's do this. Let me just code this. So, copy it to 0. Add what's in 0. So we're now holding double. Copy it to 0. We're now holding 4 times. To 0. We're now holding 8 times. Copy this to yeah, I mean copy it to 0, fine. So now we're holding 16 times, but this time we copy to 1 because we want to store the 8. So now we're holding 32 times, unless I've lost count here. And now we add the 8. And then output it. That should be 40. It's basically binary for 40. 8 and so 32 and 8. Alternatively, you could just, I don't know, add it up 40 times. Oh, okay. I thought that might be slow, Oh no. Yeah, I mean, no, that makes sense. That is fast, speed-wise, yeah. Dr. Brain, was that a Nintendo DS game? DOS game. Huh. Was it one of those educational games that were aimed at kids, or was it actually hard? get two things from the inbox. If they are equal, put one of them in the outbox. Okay. Do comments take time to read? Guess we'll find out. I guess no. I think you said numbered commands. Alright, so okay, take from the inbox, put it down. Take the next thing from the inbox, subtract that number. If we're holding 0, jump over this jump. This jump jumps back to the beginning. So if we don't have 0, then we just take the next one, yeah. Okay. So if it is 0, that means we need to pick up what was in 0. That's the original item, and deliver it. Okay. Fewer steps. Oh, it's gonna be eliminate the jump again, isn't it? Can't be bothered with that. One day when I come back to this, when I'm doing all the challenges, I'll do that. Treating all numbers equally is no longer profitable. Grab two things from the inbox, but only the bigger of the two in the outbox. Ooh, okay. They're equal, just pick either one. Repeat. It says sometimes you can't do both challenges at once. Oh yeah, definitely, yeah. Some of the challenges are, well, at least I'm going off 7 billion humans, but some of the challenges are basically contradictory. Like, you have to focus on one or have to focus on the other. Grab two things from the inbox, put the bigger of the two in the outbox. Oh, this is a classic interview question, actually, this one. The how you code at the lowest level, how you code finding the max of two numbers. So, like, you take one, let's say copy it to 0, take the next number, now we subtract the first number, wait, no, let's put that in 1 as well, put that in 1. There's probably a way to do it using the differences as well, but okay. So we've got the first number and the second number. Now, we're still holding the second number. Okay, subtract the first number. If it's negative, that means the second number was smaller. Okay, so we want to pick up the original number. Oops. And deliver that. If it wasn't negative, then we can deliver what we're holding. That's all, I guess. Let me watch this. Put that there. Put that there. No, wait. Up box. Oh yeah, whoops, we need to pick up the second number. So this is basically if-else branching, but you have to do it in a weird way with these jumps. It would be nice if they introduce if-else in this game, then you don't have to do this anymore, but I feel like they won't. I mean, so what we're holding? We're holding the difference. So we don't actually, so if we are, so we don't actually need to, hang on, let me think. Like, this is not reducing the number of steps, but, so if we are holding 2 minus 1, if we now add 1, that'll still work, right? Let me just make sure. Wait, what? 2 minus 1. No. That's if it's. Go back. What did I have before? Okay, no. In this inner one here, if it's positive, 2 is bigger than 1, so we want to add 1 back to get 2. That means we wouldn't have to store anything in 1. So that removes 1 command. Oh, that is actually past the speed. Size challenge. Let's have a look at that. Can I eliminate 1 command here? Okay, we don't need all these jumps. Hang on. So we definitely need a jump if negative. And we definitely need a jump at the end. Well, Can we eliminate one of these outboxes? Okay, so if negative branch, we've got yeah, I'm not sure. Either we get rid of one of the jumps or one of the outboxes. Alright, I don't think I'll worry about it. I think probably you can get rid of this jump and you can do something clever here that would work. Like, if you... Don't know right now. Employee morale insertion.
And that, ladies, is how I saved a bundle on my long-distance telephone service. Back to work, everyone.
Since when do officers have TVs in the kitchen? What?
The machines are not moving, and they are not communicating. Local authorities are investigating.
Absolute positivity. Send each thing from the inbox to the outbox, but if a number is negative, first remove its negative sign. Okay, similar to something I did before. We just... So we pick something up. Okay, so if it's negative, we're going to... Can't have negativity in the office. No. Okay, so if it's negative, we're going to copy it there and then subtract that twice. Otherwise, skip over that. Okay. Oh, okay, no worries. Carry on. For each two things in the inbox, send a 0 to the outbox if they have the same sign. Both positive or both negative. Okay. So if we were to somehow... Oh, okay. I'm gonna have to start thinking now, yeah, so... if I were to, say, convert the number from whatever it is to 1 or -1, so every positive number becomes 1, and every minus number becomes -1, then what? Well, then it would just be a case of... then it's easy to solve. We just have to do something with adding them or something. Or is there something a bit cleaner than that? Well, if... Well, how would I even do that? So... Okay, so... take something... Oh, I see. They put 0 and 1 here. That's convenient. That helps us do the final bits. Okay. So, all right. So let's say if okay, fine. That actually simplifies things a lot. So if it's negative, then let's say we discard the number, we pick up a 0, let's say. We place it here, and if I get so frustrated if I had 4 people staring at me and taking notes while I was trying to work. Okay, so what have I done here? If it's negative, I'm putting a 0 here. Else, if it's... gonna end up with lots of jumps here, so if it's... okay, so if it's non-negative... There's no zeros, are there? It doesn't really say, well, probably there are no zeros. Okay, so if it's positive then... not to distract you, but if you haven't played it, Baba Is You is a must. Oh yeah, I have played it. I did stream it as well. That's another one I have to come back to and do all the extra stuff, because... How many chapters did I do? Maybe about 10, before I realized you can actually finish the game fairly early. I mean, the basic ending at least. But yeah, I definitely want to come back to that. I think you can technically get the end credits even after 3 chapters, maybe? Something like that. But I think I did about 10 chapters, maybe. What am I doing here? So if it's positive, we want to just do the other number. Okay. Copy to 0. So now just watch this. Okay, so if it's negative, we should end up with a 0 there. Alright, good, good. Then what? Just do the same thing for the second number and... if... Okay, we do this again, so we end up with the second number. And then how do you... I guess we can just take that number, the 0 or the 1, subtract the 0 or the 1 which we've left there. And that might be positive 1 or negative 1, but we want to make that positive, basically. Which we know how to do as well. This is probably going to be way longer than it needs to be, but okay, so we do this again. So if it's negative, we copy from 4. We don't need to copy 2 here. In fact, we're copying to 0 either way, so let me just put that here. Okay. Copy from 4. Okay, we do this again. Copy from 5. Oh man, these jumps. Is that right? Yeah. So at this point, we don't need to store that. Okay, so now we're holding... Okay, let's have a look at this in action. So we've got a 1 because it's positive. We're putting it there. Now for the next number, we get a 1 because it's positive. Okay, good, good. Now, we want to subtract whatever's in 0. So either we'll end up with 0, which means they're the same sign, and that's what we wanted to deliver, that's 0. Or we'll end up with a 1 or minus 1. So subtract what's in 0. And then, what do you do if you've got a 1 or minus 1? Whatever I did last time. What did I do? Jump if... no, not that one. Jump if negative. I'm definitely using way more jumps than I need to, so... So if we've got -1, we want to, okay, copy to 2, subtract that number twice, and now we have the positive. Otherwise, just don't do any of that. Deliver that. Jump back to the start. Alright. That's quite a mouthful. Alright. Let's just watch this slowly. So 0, 1 represents the sign, essentially. Okay, good. Now these ones are also different. Or fewer commands. Okay. I mean, there's definitely different ways of approaching this. So you could. You could do something like you could recreate division by alright, don't worry about it, move on. I don't remember the solution, but can I give my idea? Yeah, sure, yeah. I mean, once I've solved the problem, you can say anything you want, it's fine. Is he having a nice hot coffee on the beach? Man, I always do that when I'm in like Thailand or something. They always think I want an iced coffee. I always want a hot coffee, even if it's blisteringly hot and it's on the beach. So I keep having to remind them I want it hot. And then sometimes they still forget and give me the iced coffee. What if you start at 0, add -1 on negative and 1 on positive? So, okay, so you create a -1 to begin with and put it somewhere, I guess, and then... Wait, you start at 0. I'm not sure what you mean by the phrase start at 0. So, okay, you're taking the two numbers and you're putting them somewhere first. Then you're holding the number 0. Copy the 0 and put it in pos 0. Yeah. Oh yeah, I see what you mean. Yeah. Yeah, actually, yeah, that is... I think I was thinking about something like that at the start, and that does actually sound much shorter. I'm not sure why I didn't do it. Yeah, I'm pretty sure you could make that work. Oh, it's snowing now? For each number in the inbox, send that number to the outbox, followed by all numbers down to or up to 0. Why is there a severed arm? Oh, don't worry about that. Got new commands. They add 1 or subtract 1. Oh, nice. We've got ink and deck. The result is given back to you and for your convenience also written right back to the floor. Do I actually want that extra bit right back to the floor? I don't know. Sometimes I might not want that. Okay, anyway. Wait, so you actually tell it a location? Oh, I see. Okay. Oh, that's fine then. Yeah, okay. Alright, so for each number in the inbox, send that number to the outbox, followed by all numbers down to or up to 0. Oh, okay. Pick it up. Copy it there. Deliver it. Okay, pick up what's there. If we've got 0, we could just put an outbox at the start. Is that valid? Can we do that? No, you're not allowed to. Okay. Alright, if it's 0, we're gonna have to... Okay. If we're holding a 0, we're done. But we still have to outbox it, so let's just do that. If it's not 0, that means we want to... we still want to outbox it. But we want to bump minus and put the result there. And then jump back up here. Here. No, wait, we don't need to copy anything from 0 at this point. No, if you outbox, you're not holding anything. Hang on, hang on. Ah, no, sorry, the bump goes there. Okay, okay. So the process that we're repeating is, we pick it up, we decrease it, and now if we're holding 0, we jump there, so we do one last outbox, and then we jump back to the start. If we're not holding 0, then we just do an intermediate outbox, and then jump back this loop. And these are really feel like obscure ways of replicating what you would do with an if else, but I mean it's fine. Wait. Hang on. Copy from, do we even need that? Does bump actually pick up? Let me see what is going on here. Oh, it does. Oh, oh no, this is not gonna work. Infinite loop. Okay, so that's kind of. If it's negative though, we have to make it positive. Okay, so if it's we can save one command if we do this the other way around. So we assume it's negative in general. So we can do bump plus instead of bump minus. Okay, and up here we say if it's positive, then we will copy to 0. Subtract that to make it negative. No, wait, what am I doing? No, that doesn't make sense. No. Scrap that. Okay, I got it, fine. Oh, that's annoying. So does that mean... It might be cleaner to not use bump at all, but to actually... use add 1, so we put 1 somewhere, or minus 1 somewhere accordingly. I think that's actually better. So don't use bump. Okay, so basically, if it's... Oh no, but we don't have a method of writing a number to a tile, just arbitrarily. Do we? Well, we can, but it's a bit... Oh, okay, actually, no, there's another way we can do this. We can just say if it's negative, we bump it's negative, we bump plus, otherwise we bump minus. That's much better. Why didn't I think of that? Okay. Hey, whoa. Sorry, what have I done now? Ah! No, hang on. Let me watch this. So we deliver the 2. Oh yeah, because the bump was... Oh, okay, I get it. Okay, so we actually need to pick up... If we're going down this approach, we actually need to pick up what's in 0. That's fine. Because the bump does the pickup. Wait, what happened here? Whoa. Oh, of course. This doesn't work for 0. Okay, so if the original number was 0... Wait, no, this should have been written in a way such that... So the jump, if 0, should actually be up here. No. Up here, because that's the catch. That's the bit which catches us. No, whoa, what am I doing? Where was it? Let me think this through again. Yeah, I've lost track of what I was doing. Yeah, it was there. So this works for the first 3 numbers, right? And it fails for 0 because if the starting number is 0, then it actually does the bump and it shouldn't. Okay, fine. I'll just put in a hack. Just say if we have 0 to begin with, then just jump to the end. You probably could have written the for loop in a sensible way that it actually accounts for 0 naturally. I don't think that's too hard to reduce the size. Let's carry on. Yay, we're onto multiplication. For each 2 things in the inbox, multiply them and outbox the result. Don't worry about negative numbers for now. Okay. We've got labels. They can help you remember the purpose of each tile on the floor. Just tap any tile on the floor to edit. Alright, thank you. I hate it. Why are they copying? Okay, why is that starter code? I don't know what they're getting at there. Right, so for each 2 things in the inbox. Okay, fine, we just use... Okay, get rid of this. Alright, so we pick that up, put it here. Pick up the next number. So we need a... Oh, okay, so we're going to need a counter, aren't we? So, let's say our counter is this number itself. 5 is the number we multiply by, but it's also the counter. So let me explain what I mean. So put the counter in 4, let's say. Okay. So we take the next number, and then we do this repeated step. We add whatever was in 0. And we copy it to 1. And then we decrease the counter. And at that point we are holding with the counter as well. That's the result of doing the bump. If it's 0, wait, if it's 0, what does that mean? We might be off by 1 here or something. So if it's 0, we're done? Or it could be if... Well, let's just try it and see. And then we need... If it's not 0, we just... So we need to store this second number in 1 to begin with. Right, so now our repeated process is to pick up whatever's in 1, add whatever's in 0, put it back in 1, decrease the counter. Let's just watch it and see what happens. Put the 5 there, that's our counter. Right. Now we take the 4, put it there, add... Wait, no, what am I doing? Hang on, stop. No, we don't add 0, we add 1. We add itself. Wait, so we don't need to have this 4 here. 0 is the counter. Okay, got it. Okay, so 9, we put that there. 4, put it there. Now we add it to itself. Decrement that. Add it to itself. Oh, something's... Hang on, what? What was the starting number? 8. Oh no, that's okay then, yeah. No, something's wrong then. Oh no, I was doubling each time. Whoops. No. Yeah, we add and store the result in 2, not 1. So otherwise it's growing exponentially. Okay, do that. Wait, what's going on? So we put the first number there. Stop. Go away. Oh, we put the first number in 0. Put the second number in 1. Okay. Now the repeated bit is we... Oh, there's nothing in 2. Yeah, okay, fine. Copy to 2 as well. So put the 1 there, put the 4 there. Huh? Oh, yeah, of course. Okay. If it's 0, we have to pick up what we put in 2. This finishes... No, the counter's not quite right. We need to decrement it once to begin with. Right, wait, anyway, let me just fix... There's two things wrong here. So, when we are holding 0, we actually have to pick up whatever's in 2 to finish off with. Right, the other thing is, I think we need to... decrement it once to begin with. Damn it. Okay, seems right. Alternatively... Oh god, what have we done? Of course, this isn't going to work with 0. Yeah, so bumping to begin with is... I mean, we just shouldn't have to do that. Hang on. Okay, I need to go to the toilet as well. Alright, so I think the cleaner way is to get rid of this bump. We need to... And the jump, if 0, should actually happen... at the start. Wait. Wait. I'm getting confused. Right, it's actually fewer instructions if we use the second number as the counter, but I can't be bothered to do that. So let's use, if we're sticking with using the first number as the counter, we can, what we do is we pick up the first number now. If it's 0, we skip to the end. So that stops us from doing any arithmetic operations if it's 0, which can happen to begin with. Alright, will this work? So we know it already works for... Damn it. I did one too many now. Because I removed that bump, but I didn't... Let me just watch this again. So when it's 1, we want to finish. But... Alright, a way to clean this up then is to, okay, get rid of this here, this number that we're putting in 2. We will use it later on. To start with, we just pick up the 0. Right, so we're holding 0 to begin with. And then we say, move this all back to the end again. Okay, so we say, get rid of that. Yeah, so we add 1, put the result in 2, do the bump. That all works if we're holding 0 to begin with. And then to maintain the invariant, we have to then pick up 2 to carry on with that number. Alright, have I... Okay, let's just watch. I'm getting lost now. So now we pick up 0. Now we begin the process. We add 3. That's like the identity. And then... I forgot what the original numbers were. Let's just see if it works. Split this up a bit. Okay. Bollocks. Wait, we still get the 0 problem. Right, it was working until we got 0 as the counter. Okay, okay. Oh yeah, because the whole reason I moved jump of 0 to the top was to account for 0 being the counter. So I can just add another... I can just say, oops, take that out. Alright, whatever, let's just do this. Let's say we pick up whatever we've put in the counter. If it's 0... No, what am I trying to do? If it's 0, we just output 0 because that's the correct answer. And jump back up. Okay, will that work? Nice. Oh, this is actually quite short code. Can I eliminate one instruction from that? Probably, because I thought what I did was a bit hacky. Like this jump. We should really be using the second number as the counter, not the first number. If we do, okay, let's say we're using the second number as the counter. So first number we store, second number. We store, yes. Take that out, because we're holding the counter now. If 0, we jump to the end. Okay. Now, every time we're using the counter, we have to basically swap everything around. So, this one changes to 0. This one changes to 1. That should be it, right? I've just swapped the two places. And we've eliminated one instruction there by doing that. Alright, not worried about speed. The inbox is filled with 0 terminated strings. What's that? Ask me, your boss. Add together all the numbers in each string. When you reach the end of a string, marked by a 0, put your sum in the outbox. Okay. Doesn't sound... I don't see anything difficult there, so... Okay, so in the bit we repeat is... We... pick something up. Well, I wanted to... Okay, just do it this way. Pick this up and put it somewhere. Wait, no, if we can't start with a 0, can we? That would be a bit cheeky, but it seems like we don't. Okay, so if it does, we'll worry about that when it happens. So we pick something up and put it in there. Pick up the next number and we add hang on, let's see if this works. Forget about that. Can I do this? No, okay, it doesn't default to 0, fine. So, put the first number in 0, pick up the next number, add whatever's in 0, and store that in 0. And just repeat this bit here. So for now, this will just keep adding all the numbers together. Putting the result there. Good. Okay. Now, if we ever pick up a 0, I assume it can't happen here. So it might happen here. Then we break out. Pick up whatever is in 0 now. Outbox it and jump back to the start. This will work as long as there's no empty strings. Oh, there are empty strings, damn it. Okay, in that case we need... We could just throw in another jump F0. What the heck happened there? If it's 0, if if it's 0, we actually want to output the 0 because it's a vacuously empty sum, whatever. Okay. Commands. Oh, it was the speed. 11 commands. Yeah, because we've got 2 jump if zeros, but... Yeah, I don't like this having to... We didn't actually use the 0 that's residing here, did we? It shouldn't be too hard to eliminate one instruction. We don't need this one. We can say, hang on, jump above the copy to 0. And get rid of this copy to 0. That's equivalent. There we go. Fibonacci visitor. Ooh, Fibonacci. It's just gonna be produce the Fibonacci sequence, isn't it? So we want to output the full Fibonacci sequence. Okay, it doesn't actually tell us what the Fibonacci sequence is. So the Fibonacci sequence starts with... okay. Some argue it starts with 0. But okay, in this case it starts with 1 and 1. And then every next number is the sum of the 2 previous terms. So we're gonna have to repeat all this, so we have to keep it clean so that we're able to... okay, so we've got a 0 to start with. That's actually... Okay, up to but not exceeding that value. Oh, it's not a counter. Oh, okay. That's fine. Fine, so just take the number, put it there, that's fine. Okay. Alright, if we want to start a Fibonacci sequence fresh, we want, okay, I would say at the very start, let's bump 9. Right, we don't want the 0, we want the 1. So we'll end up with a 1 there, right? Yeah, okay. Okay, now, we take the number, store it. Okay, so we want to now take our stored 1, put it in 5. Okay, so yeah, we store the first, so this is setup. So we're putting a 1 in 5, and we're putting a 1 in 6. Okay, so there should be a 1 and a 1 there. And at this point we can actually do the check. We can say, okay, if the number we're holding could we ever get a 0? I'm guessing, let's just hope not. Okay, so up to but not exceeding that value. So if we get a 1, we actually have to output both 1s. Yeah, I guess, yeah, you would. Okay. So we want to we just have to do this. Hang on, let me think. Okay, okay. Let's just. So we picked. Okay, start again. Start my train of thought again. We've changed that to a 1 because I want that to be a 1. We now pick up this number and we put it in the first slot. That is our comparison. Every step of the process, we're going to compare. If we ever exceed that number, they could give us a 0. Let's account for they might give us a 0. Yeah, I'll do they give us some more information here? Okay, yeah, I know what the sequence is. It seems like it's always going to be positive. I'll assume it could be 0 because I don't want to have to go change it again if it could be 0. Alright, let's assume it could be 0 or even negative or something. We're gonna need... Alright, so we're gonna need to copy from... We're gonna make a fixed 0 and a 1. So that's gonna be the 1, that's gonna be the fixed 0. So we've got a 0 and a 1. Never change those. Okay. Alright. So... I mean, we don't even need to do that. We've got 0. We know what to do with it. Let's take that out. Alright, so we take... Okay, so the setup, the initial setup. We take a 0. We put it in 5. We take another 0. We put it in 6, but we change that to a 1. So this is like the pre-term of the sequence. The next terms from now on are going to be 1, 1, 2, 3, 5, 8. So we're kind of imagining there's a -1th term called 0. I think this makes this easier. So if we look at this now, take these ones out. Copy from 9, copy 2, 5, copy from... Wait, that should be 9. Okay, we can just do this. Okay. Okay, good, good, good. Right, that's our setup. We now take the number here, put it there. Okay. Now, as soon as this second number exceeds this comparison number, we finish the process. So we could say copy from six. Subtract the comparison number. If we get a negative number, that means we've exceeded. No, sorry, wait, what? Okay, do it the other way around. copy from 0, subtract that number. If it's negative, then we go back to the setup again. And we take a new number, so that will just... Yeah, okay, that'll set it up again. Right. If negative... Okay, just test that. Okay, fine. Right. Now we actually begin the Fibonacci calculation. So we pick up copy 2, copy... Wait, what? No, take that out. Take that out. What have I done here? Copy... No, that was correct. Copy to 0. Okay, copy from 0. It looks weird, but that's because I'm going to insert a jump between those two. Let me just put marker there. Okay. Oh, you can't type. Whatever. Not the most helpful of labels. I thought you could type into these. Alright, so so the loop begins from here. We take the comparator, we subtract the second number. If it's negative, we're done. We reset everything. Okay. So if this is not happening, then we can now produce the next term. Well, no. We can now output the second term here. So pick up the second term, outbox it. Now we want to produce the next term. The next term is going to be the sum of these two terms. So we pick up 5 and pick up the first term, add the second term, store it, let's say in this spot here. Now we have to shift everything. So then we have to move whatever's in 6 to 5. In fact, instead of using 3, let's use 7. Then it kind of looks nice because you're shifting things left. Alright, so 6 goes to 5. 7 goes to 6. And then we jump to the beginning of this loop here. So now we have two new Fibonacci numbers. No, one new Fibonacci number, but it's all been shifted to the left. All right, let's watch it slowly. So we put the 0 there, we put a 1 there to set up. All right, that's the comparator. We compare. Oh, stop. Okay, no, that's right. We output the 1. Then we move everything to the left. We get a 2. That goes there. Move that there. Move that there. Now compare. So we output the 2. We get a 3. That goes there. 2 gets pushed to the left. 3 gets pushed to the left. So we keep going. The key is, do we stop at the right place? So 1, 1, 2, 3, 5, 8. Ooh, nice. So if they throw a 0 at us, this will handle that. But it is just a couple of extra steps we needed to do that. Beautiful. Interesting. Because I think I used extra commands to handle the possibility of a 0. Maybe I didn't. I think the way I finally settled on was actually kind of clean. Yeah, no, yeah, I don't. It now doesn't matter. I think the way I've done it here is fine. Wait, what was the speed? Did I get the speed one as well? Just wait. The Fibonacci sequence. There's no end to the numbers of interview-like problems you can come up with that relate to the Fibonacci sequence. And you'll always stump people with them because it's always kind of tricky. Yeah, I'm not worried about the speed. Okay, let's keep going. The littlest number. To reduce our carbon footprint, management is requesting the smallest numbers only. For each 0 terminated string in the inbox, send to the outbox only the smallest number you've seen in that string. Are we gonna get... No, we won't get empty strings this time. We did before, but this time it wouldn't make sense because there's no smallest then. It'd be negative infinity or whatever. Alright, so okay, I see what we do. We take... Oh, you have 3 different tabs here, that's nice. So you can work on the 3 different challenges separately. Store them. Maybe you were able to do that in the second game, I can't remember. Yeah, probably you were. Alright, so I'm just checking Discord. Okay. So basically we want to store the smallest we've seen so far. So we take a 3, we put it in 0. Okay. And the invariant we're trying to maintain is 0 always contains the smallest number we've seen so far. So we now pick up second number. So if it's bigger, we don't want to do anything. If we pick up a smaller number, then hang on. Okay, so we pick up a new number. Let's subtract whatever's in 0. Now, if this is negative, then we just want to add whatever's in 0 again. That will get the number we were holding. And then we want to store it in 0 again. And if it wasn't negative, then I guess we just don't do that. Okay, that's sort of the loop, except we need to deal with 0. So when we pick up this number here... Okay, so this loop gets repeated like that. Let's just watch it in action. And then we end up with the smallest number. Okay, so now, but if we're holding 0, then we have to pick up the smallest number and outbox it, and then another jump, I guess, back to the start. Cool. That's fine. Mod module. So like modular arithmetic. Outbox the remainder that would result if you had divided the first by the second. So it's clock mathematics, basically, yeah. So we're doing A modulo B. So basically we take the first number put it in 0. We take the second number, put it in 1. Now pick up the first number. We want to keep subtracting the second number until we are... Oh, here's a way we can do it. We can just keep subtracting the second number until we are negative. Then just add the second number to get us back into the positive, but we are going to be... Wait, what am I saying? Yes, that's correct. Okay, just keep subtracting the second number. I really want to jump if positive. I keep having to invert these, so... And we keep subtracting the second number until we're negative. Once we're negative, we just add one more of that first number to get back into the positive, but we're also going to be strictly less than the second number. So then we outbox that number and go back to the beginning. So we put a 5. So the answer should be 2. So we're taking the first number. We repeatedly subtract 3 until we're negative. Add 3 to get back into the positive. Yeah. In other words, we're trying to find the largest... We're trying to stop when we're just below the second number. That seems like it might be the smallest code size. Wow, I beat par. And I beat the speed challenge as well. Cool. Okay. Next one, cumulative countdown. I need some jackfruit. What's the purpose of this assignment? Volume beneath staircases. So this is, what, triangular numbers? Triangular numbers are where you sum 1 to n, but you could also, I mean, there's a formula for that, and that's what, half n minus 1? But, so, would it be faster to implement that formula? We take n, put n minus 1 in a separate box, multiply them together, add you half. I don't think that's faster. If there was a... I don't know how to half. So we'll just do it the adding up way. I mean, it's not that hard, it's just a variation of what we saw before. So we take this first number, put it in 0. And now, we're going to repeatedly decrement our number. Add it to whatever was in 0. And store it there. Now this will go on forever, let's just watch it do that. Damn it. Okay, fine. Copy it to 1 as well. So. See, that's why it bothers me that bump actually does several different instructions, some of which we don't want, but that's fine. That's working, yeah, but it's not stopping correctly, but that's fine. Okay, now to 1. So if whatever's in 0 is 0, we just output. No, not if what's in 0 is 0. It's if it's what is in 1 is 0. We have to pick up 0. I feel like I might be able to lose 1 or 2 instructions here now. Oh, that was okay. Small divide. Remember last time when I told you you didn't need to divide? Now you get to. Wonderful. Each 2 things in the inbox, how many times does the second fully fit into the first? Don't worry about negative numbers. Divide by 0 or remainders. I don't remember which previous assignment we would want to copy and paste here. I mean, there was multiply, but that's kind of different, isn't it? I think this is actually easier than multiplying. Alright. Take the first number, put it there. Take the second number. Put it there. Pick up the first number again. Subtract the second number. Over and over again. And put the result back in the first number and increment a counter. Okay, we need a counter. Let's say to begin, before we do anything, we pick up the 0 that's there, store it just next to it there. So that's our temporary counter. Alright, so in this loop that is repeating from here. So we pick up the number, subtract the second number, put it back, and then we increment the counter. So as soon as we hit the negative, hang on. We don't want to do the bump if we hit the negative. So let's say if we're negative here, jump here. Pick up our counter. I'll box it. Repeat the whole process. So our counter is just counting how many times we just subtracted the second number until we got negative. Alright. Okay. Sort these three things. Ooh, interesting. Trickiest bit is probably finding the middle value. We could use a sorting algorithm like bubble sort or something, which is easy to code if you're doing swaps or So how many passes would you need if you're doing bubble sort? You would need 2 passes. Yeah. So how do we do that? So, okay, so this code is putting the 3 numbers here. Okay. So now... I just have to... I don't need to use loops here. We can just write out bubble sorts fully. So, what do we do? We pick up the... So basically we're saying we want it to be smallest to largest, right? Smallest on the left, largest on the right. So if 1 is smaller than 0, we need to swap those 2. So we pick up 1. Let's just rearrange these to make this... Okay, so we're now holding 1. Okay, so we subtract 0. So let's just put the... just sig... No, don't do that. Okay, so we subtract 0. If what we're holding is negative, that means these two need to be swapped. No, do this the other way around. Now let me think. No, because it's jump if negative, we would rather skip stuff if it's negative. So do this the other way around. Say... we're holding on to 0. Okay. Subtract 1. Alright. It's not negative. We would like it to be negative. If it's not negative, that means they need to be swapped. I mean, if they're equal, they don't need to be swapped, but it doesn't matter. So so the swap, we have to pick up the 1. Put it in 5. Pick up the 0. Man, I'm gonna have to do all of this four times. That's not too bad. Copy to 1. Now pick up the temporary available 5. Put it to 0. That is one swap in the first phase. Now we have to do all of this again for 1 and 2. Then we have to do it again for 0 and 1, and then again for 1 and 2. That's fine. So we copy from... basically we need to copy from... let's put a marker here. And a marker here. So okay, we could eliminate instructions here by finishing on the 1. Let's just try and optimize this a bit better. So swap this around. Copy from the 0, put it in 5. Copy from the 1, put it in 0. Copy from the 5, put it in 1. Okay, now we're holding on to 1, ready for the next step. So now we subtract 2. We do jump if negative and just copy what I've done up there. So copy from the 1, copy to 5, copy from the 2, put it in 1, copy from the 5, put it in 2. Alright. This is one phase, and then we need to do second phase, so these two again. Let's just see that in action. So we've got 7, 5. Okay, this is all in sorted order, so fine. Try again. 6, 2. Okay. It's in sorted order again. We have something that's not in sorted order. It's always alternating between these two. Alright, fine. Doesn't matter. And then we just have to go back. See, I would save a lot of instructions if I were now to jump back and have some sort of counter. Can't be bothered to do that. It's actually easier just to copy all the instructions. So now we go back to 0. Subtract 1. Wait! No. Yeah, no, this is correct, yeah. Okay. Subtract 1. Negative. So we copy from 1. Store in 5. Copy from 0. Copy to... Hang on. Let's just do it the way we did it before. Copy from 0, store in 5. Copy from 1, store in 0. Copy from 5, store in 1. Then one last time. And this one is just this, so sub 2. Oops, didn't move that. Right. Sub 2. Okay, then jump with negative. Alright, and then from then on it's copy from 1. Okay. Copy from 1 in 5. And copy from 2. Copy to 1. Copy from 5. Copy to 2. Then what? We're supposed to output smallest to largest. Okay. Now take 0. Outbox it. Take 1. Outbox it. 2. Outbox it. Let's try this then. Damn it, what happened there? It was going well. I have to look at it from the start. 752. How do we pause? Oh, we've got that, I guess. I don't know. Three. Oh, I'll just watch it slowly. Oh! So, yeah, no. Something's wrong here. Sub 1. Jump if negative. Ah! Yeah, no, this is wrong. There should always be an instruction before each of these. So here, we sub copy from 1. Here we copy from 0. We already did that. Here we copy from 1. Because we don't know what happened previously. Okay, try that. 2, 4, 8. Okay. 2, 4, 9. I mean, I could probably halve that. Well, not halve it, but reduce it by quite a lot by just doing an inner loop, which does all those phases, the 2 phases twice. I just need to put a 1 somewhere so that I can do that. Or some sort of counter, I don't know. Yeah, it's fine. That's bubble sort. Man, I can't remember the last time I've had to do bubble sort. I think back in school. You don't use bubble sort anywhere in the real world, but I mean, it has its use in the sense that it's sort of the simplest one to implement if you have the means to do swaps adjacent, but you don't really have the possibility, for example, to shift arrays or to use digits or things, and any of the clever things that are used in sorting algorithms. Like, if you wanted to implement merge sort, you could actually do it, but no, you couldn't, because you'd have variable lengths of subpartitions. It would be a mess. Insertion sort? No, the problem with insertion sort is you have to shift the whole array when you're inserting an element. Yeah, I think bubble sort is probably... If there was a way to pick a random number, you could just randomly shuffle the list over and over again until it happens to be sorted, which would probably be quite a relatively few commands. Take a long time to run. Not even that long to run, to be honest. Alright, I think I might be done. Well, I don't have time. I can keep going a couple more maybe. Storage floor. You can access slots on the floor indirectly. Imagine each thing in the inbox is an address, and each address refers to a tile 0 to 9 on the floor. Pick up the letter at that address and outbox it. So copy from 12 is what we've been doing. Copy from... Ah. Copy from the contents of 12. Okay, fine. So whatever's stored in 12, take from that. Okay, okay. So we take our number. Have to store it somewhere, put it in 10. Now, copy from... using the indirect addressing. Outbox it. That's it, right? Key. Yeah, that's very basic and it's optimal as well. String storage floor. Not read or discuss what they say. It would be impolite to read messages intended for someone else and forbidden. Each thing in the inbox is the address of a tile on the floor. For each address provided in the inbox, outbox the requested item from the floor. And all following items on the floor until you reach a 0. Repeat. Okay. It's not too hard. So we take our number, copy it to 24. Copy from what we've put there. Outbox it. What if... Can we get pointed to... Okay. And then bump 24. So that just works infinitely. Let's just watch it work. No, hang on. Did it pick the right ones? Let me see that again. 4 is the T, and then the H. Got it, okay. If we pick up a 0, we just go back to here, don't we? The target X is awake. XXX. Take this XXX. Alright, I won't question that. So these are kind of mini tutorials for working with strings. Oh wow, we're actually quite far into the game. Oops, no, go back. I mean, yeah, it's a short game. Well, we did all those. Yeah, okay, they are quite short. String reverse. Ole. Ole. For each 0 terminated string in the inbox, reverse it and put the result in the outbox. Repeat. Ooh. Are we guaranteed that they're gonna be... I guess we would have... Okay. Okay, so we take a letter. Are they... Alright, we might be okay if we, make another 0 here. So we can replace that one. So... we take a letter. We copy it to whatever 13 is pointing to. We bump 13. And repeat. Let's just watch that in action. Cool. Right now, if we pick up a 0, the next phase, is we're gonna have to unbump this. Pick up whatever is referred to there. Outbox it. Do that. And if we get to a negative number here, because at this point we'll be holding whatever's in 13, we just repeat the whole thing. Let's watch that. As long as the words are not too long, we're fine. God. God, more. What? God, more. Is someone yelling out during sex or something? What? God, more. 11 or fewer. Can I eliminate one command here? Oh, dog. It's dog, not God. Dog, more. That's even weirder. We can. This will return to 0. We can avoid. Okay. Take that out. Okay. We refer to 14 instead. But the jump if negative, we're gonna have to change it to so if we pick up a 0, we're now here. We'll have to just pick up whatever's here and jump. I don't see a cleaner way of doing this. could probably get rid of one command then. It's good enough. For each thing in the inbox, send to the outbox the total number of matching items on the floor. Wait. How would you check if two letters are the same? Huh? Am I missing something obvious here? How would you even compare two letters? We haven't. This is all arithmetic stuff. Yeah, that's what I would like to know. Subtract them? Okay, well, fine. Let me just test this out. So let's do B minus. Let me just bump 14 a couple of times. Okay, I want the X. Yeah, that's fine. Okay. Do B minus X. Yeah, what's he holding? Oh, it gets converted to an integer. Well, that's okay, that's good. Okay, so what was it? We each take the inbox, send to the outbox the total number of matching items on the floor. Alright, I can see mostly how to do this. How do we... Okay, so we pick up the letter we want to compare. We put it, say, in 15. Then we pick up... Okay, so in turn we pick up each letter one by one. We subtract 15. Hang on. Alright, subtract 15. If they equal, we would get 0. Otherwise, we go back to... Otherwise, we would have to bump plus 14. So if they are equal, we have to outbox. We have to pick up that letter again. No, 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 no. We're not outboxing it. We are keeping another counter. Ugh, okay. Alright, it might be better to make a couple of more zeros here. So let's copy from there, put this here, and also put it here. So one of these is the counter for the addresses, the other is the second one is the total. Right. So 18 is the addresses, so yeah, we're using 18. So, okay, so we subtract that letter. Why did I... Oh, that goes here. If it's... What? Alright. Let's just take that out. Let's just bump up preliminary. Okay, just bump up 18 first. And then bump it again. Decrease it in this loop. That makes this cleaner. So it starts one above what it should be. So we remove one. We don't need to copy from... Oh yeah, we do need to copy from. Oh. Okay, so we decrease it. So it should be at 0 to start with. So yeah, we copy from whatever it's pointing to. We've got the letter. We subtract the other letter. If it's 0, we go down here. If it's non-zero, we just... It's the other way around. No, okay. We increase the address and do that again. So if it was 0, we have to basically just bump the total and jump back here. So we can sort of do that, I guess. I don't know. Alright. If we ever pick up a 0 instead of a letter, then we're done. We just need to pick up the final total, outbox it, and then jump back to the start. Okay, let's just watch this. So we're setting up, but that's the address, that's the total. take the first letter, put it in 15. Now it's telling us to go to B, subtract it. Nothing. Alright, go to the next address. A. Alright, we get the picture. So when we get to C, yeah, okay. Nice. 17. Oh, for goodness sake. I mean, it'd be nice to. No, that has to remain a 0 because it shows us we're at the end of the. Unless there's some way. Is there some way we can check if we have a letter? No, not really. Okay, so can we eliminate a command? I don't like this bump minus bump plus here. Can we not do that? So we're copying from... Why did I do that again? Because if I didn't do that, then we would have to bump when. Wait, no, yeah. The problem I had before is no longer a problem. Okay, so the bump, actually we can do here. And take that out. Okay, try that. Yeah, that's fine. It's these weird if-else implementations. Just use a hash map. That's the way to do it. Where's Carol?
Hey, where's Carol? Oh my god. This coffee is amazing.
Okay.
Ladies.
My office was never like that.
Previous reports of
Then we didn't have any ladies in my office.
Everything equals 100% fine. Whether within pleasant tolerance parameters or human skin layer, you're all going to be fine.
Valve incinerator. Send everything from the inbox to the outbox except for vows. Oh. It's basically what we did before, right? But if we find a vowel, can we copy our code from before? No, not this one. Yeah, I know, but it's... Damn it, can I just paste it and change the numbers? Oh, bollocks. Alright, just do what we did before. Unless I were to go back and change the numbers. 6, 7, 8, 9. Oh, I can do that. Let's do that. So we want to change the numbers here to... That will be 5. Wait, can I... Hang on. Go back. Copy this. Paste it here. That's how we do it. Okay. So that we're changing to 5. This one we're changing to 8. This one we're changing to 9. This one changed to 6. Okay, copy that. Yeah. Okay. There we go. Right. So copy from 5, 8, 9, and 6. Okay, so this program is counting the totals again. Which is not what we want to do, but it's okay. Okay. Now, modification is if we get a 0. Don't want the vowels, so if we get a 0, actually we jump straight to the start and get a new letter. Right. Otherwise we continue. We don't actually need 9, we don't need the total. We do need to bump the address. So if we pick up a 0, we go there. We don't need this. We pick up the letter itself, so it's going to be 6. All right, let's see that. Alright, that should be fine then. Another severed arm in the room. That was sufficient. Alright. Almost there. Duplicate removal. I might be finishing soon, so I might not have time to do this. Let's have a look at it. There's a part of the window missing? Okay. Send everything from the inbox to the outbox unless you've seen the same value before. Discard any duplicates. Excuse me. Interesting. How many inputs do we get? There's probably enough spaces. So I think again we can paste what we had before. Alright. So we're going to assume there's already a list of things here. Actually, okay. Let's put a 0. Put it here. We're gonna put a list of all the things we find along the top. Alright, so to begin with, we've got a 0 there, but we can assume we have a bunch of letters and then a 0. So we do what we did before. Copy from, let's say, 14. Copy to, that's the address. We don't need a count. Okay. So we copy from 14, put it in 13. Then we take the inbox and put it in, let's say 12. So we need as much space as we can manage. Okay, that's the comparison. Now we copy from the address. If it's 0, we're done. So we take what was in 12, outbox it and jump. There were no duplicates. Let's watch that work for a couple of letters. Okay. That's fine. Alright. If we do find a duplicate, which happens here, wait, that sub has to be 12. That bump should be 13. If we find a duplicate, we jump here. This is new code. So we have to basically we have to Alright, we have to first reset the address. So reset the address to its original value. No, what am I saying? So we found a duplicate. We want to store it in this list. Gonna need a boolean then. So we keep a count of how many times we find it in the list. So it'll be 0 or some number. Hang on. Alright, so we keep the count that we were doing before. Let's store it in... We're running out of space here. Alright, we'll store it in 11. So, copy from 14, store... 14 is a... Man. No, this is okay. This is okay. Fine. So copy from 14, copy to 13, copy to 11. Let's say 11 is the total. Right. So if there's a 0, if we find a duplicate, we want to bump that total. Otherwise, we don't bump that total. Okay, but either way, we bump the address, we carry on, blah blah blah. Now, we've got a total. If we've reached the end of all of that, then we go here. Don't worry about that jump. So, the last thing we need to do is check what the total is. If it's 0, we are good. We pick up the letter, which is stored in 12. Oh, I can put labels on these things, can't I? So this is... Oh, I can't type. Forget it. Right. Pick up the letter. Outbox it. Okay. We're done. If it isn't 0... then we need to that letter we've... No. Yeah. We don't... If it isn't 0, we don't do this. We don't output that number. But if it is 0, we also need to put that number that we have, put the letter we have. Ah, okay. Before we outbox it, we also have to store it in our data. So we copy to... the address, wherever the address is pointing, which is going to be where we found the 0. We overwrite that 0. We have to increase the address. Write a new 0 there. Now we've sort of done everything, haven't we? Okay, and then we can output that letter. If we had a duplicate, we don't have to do anything. Alright, let's try this. Oh man. Okay, I didn't put the letter. The 12, we pick up the letter there. Hang on. If it's 0. No, this is wrong. Why are we writing over the address? If it's 0, there were no duplicates. So we have to pick up the 0, okay. Store it where the address is pointing to. Bump the address. No, I'm doing this wrong. We have to pick up the letter, put it in our data, bump the address, pick up a 0, put it in our data to null terminate it. Now pick up the letter and output it. God, this is so confusing. So E, this is the interesting bit now. Yes, we skipped it. Beautiful. We used quite a lot of code there. Alright, I'm done. That's fun. We've just got a few left. Prime, Factory, Digit Exploder. I mean, that's definitely going to be enough for a stream. It's probably harder stuff as well. Alright. Alright, thanks for watching. See you next time.